Good morning, everyone, and welcome to this lecture. This is lecture number 3. We are dealing with a combination of capacitors. Apart from combination of capacitors, we will also be doing combination of resistors and try to wind them as well, because everything, whether it is resistor or capacitor, it is same. Combination of capacitors. Before going on to this topic, let us have a look at what we had done in the previous class. In the previous class, we had started we had seen the types of capacitors. We have seen the parallel plate capacitors, and we have understood the meaning of what is a parallel plate capacitor. How do you find the charge on the capacitor, and how do we find out the capacitance of a capacitor. We had seen the formula of the parallel plate capacitor. We had seen the formula of what should I say, spherical
Spherical.
capacitor, cylindrical capacitor, and we had solved a couple of problems. We have also seen what do you mean by a battery or a cell. A battery or a cell gives, or in a circuit, it provides the potential difference so that charges can flow. Charges can only flow when there is a potential difference. Charges can only flow when there is a closed circuit. So when the circuit is closed, we need a battery or a cell which gives you the potential difference. Every battery has a negative terminal which is at a lower potential. Every battery has a positive terminal which is at a higher potential. Charges, the flow of positive charges in the circuit, outside the battery, it is from positive terminal to negative terminal. That is known as the direction of conventional current or direction of current. Remember, battery does not supply charge, it only gives a potential difference, it only creates a potential difference between any 2 points in a circuit. Now, a battery can be getting charged or a battery can be getting discharged. If a battery is getting discharged, inside the battery, positive charges will move from negative to the positive terminal, and if the battery is getting charged, positive charges are moving from positive to negative terminal. Do we understand this? Yes or no?
Yes, sir.
Then we had seen what do you mean by EMF of the battery or a cell. EMF of a battery or a cell is the work done per unit charge in moving a positive charge from the negative terminal to the positive terminal. That work done is known as the EMF of the battery. You can also define EMF in this way. It is the potential difference across the battery terminals when the battery is in open circuit. Ideal battery and real battery. In ideal battery, there is no resistance, and the potential difference across the battery is always equal to the EMF. For a real battery, the potential difference is not equal to EMF when the battery is connected. In fact, when the battery is getting discharged, the EMF, the voltage difference is less than the EMF. When the battery is getting charged, the voltage difference is more than the EMF. Charging and discharging. If the battery is discharging, work done by the battery is positive. If the battery is charging, the work done by the battery is negative. We all understand this. We all remember this.
Yes, sir.
That takes us to the next heading. We will go through it very quickly, and that next heading is the combination of capacitors. The first combination, the first type of combination is known as the series combination. Series combination of capacitors. What happens in series combination? Everyone knows this, yes or no?
Yes, sir. Current remains same.
In series combination of capacitors, same charge will flow through all the capacitors. Same charge will flow through all the capacitors. Here there is a battery. You can write the battery like this also. The same charge flows, as you can see, the charge which is flowing Q, the charge which is flowing Q is same through all the three capacitors and the same charge is put on all the three capacitors Q. Such a combination is known as series combination. Initially uncharged. Remember, the capacitors are initially uncharged are connected as shown in the figure such that the same charge flows through all the capacitors get the same charge, then the combination is known as the series combination. Do we understand this?
Yes, sir.
The potential difference across each capacitor, the only formula that we had done is Q is equal to CV, so V1 will be equal to Q by C1 and so on. Do we understand this?
Yes, sir.
So basically what is going to happen is we can find out the value of Q1. We can find out the value of V1, V2, V3 and so on. Yes or no?
Yes, sir.
V1 will be equal to Q by C1, V2 will be equal to Q by C2 and V3 will be equal to Q by C3. Yes or no? No, yes.
Yes, sir.
We can also write this in this way that V1 is to V2 is to V3. That means the potential difference across the capacitors will be in inverse ratio. Do we understand this?
Yes, sir.
Everyone is able to understand this, or this is going above our head saying bye bye?
Understood, sir.
Okay, now remember, the number of ways in which you can remember all these things, the better it is going to be for you. So V1 you can write it in this form also. V1 will be first, listen to me, then I will give you time to note it down. V1 can be written in this form also. V1 will be equal to 1 by C1 divided by 1 by C1 plus 1 by C2 plus 1 by C3 into V. Yes or no?
Yes, sir.
Similarly, you can write V2 as 1 by C2 divided by summation of 1 by C multiplied by V. Yes or no?
Yes, sir.
Okay. So remember all these small tricks. Now what we can do is I can replace these three capacitors by a single capacitor that is known as the equivalent capacitor. Yes or no?
Yes, sir.
This equivalent capacitor will have the same voltage V and this equivalent capacitor will have the same charge Q. Now this Q, the charge coming can be written as C equivalent multiplied by V. Yes or no?
Yes, sir.
And the value of this C equivalent, anyone knows what is the value of this C equivalent? This 1 by C equivalent will be equal to 1 by
I
C1
see 1 plus
plus
1
1
by
by C2 plus 1 by C3. If I write it in summation form, it will be summation of 1 by Ci. Do we understand this?
Yes, sir.
This type of combination of capacitors is known as the series combination. Series combination. Do we understand this?
Yes, sir.
Since I don't have any space left, so now I'll give you time to note it down. Let me know once you are done. Then we can move ahead and write these important points. All these points are questions. They're going to come into exam as question. In series combination for capacitors, remember we are talking equivalent capacitance is always less than the smallest capacitor of combination since they are added by first inversing them, adding them, and then again inversing them. The series combination, in series combination, the equivalent capacitance will always come even smaller than the smallest combination, smaller than the smallest capacitor. Do we understand this? So if you have two microfarad, 3 microfarad, 6 microfarad, these three capacitors connected in series, the equivalent capacitance of this system will come even less than 2 microfarad, which is the smallest capacitor. Do we understand this? Yes or no?
Yes, sir.
Energy stored. Now since We have three formulas for energy stored: Q square by 2C, or half CV square, or half QV. Here Q is same, so you can use this formula. Do we understand this?
Yes, sir.
So Q of the combination can be written as Q square by 2C. You can also write U1 is to U2 is to U3 will be equal to 1 by C1 is to 1 by C2 is to 1 by C3. Are you able to understand what I am saying here?
Yes, sir.
Now remember, whenever these capacitors are getting charged, they are getting charged by a battery, so that battery is doing some work. Yes or no?
Yes, sir.
The work done by this battery will be equal to Q into the EMF of this battery. And whenever you find out this ratio, this work done by the battery will always be 2 times the energy stored. Basically, what it means, half of the energy supplied by the battery, you can think it of as energy supplied by the battery, or you can think it of as work done by the battery. Half of the work done by the battery is giving the circuit potential difference, the battery is making the charges to flow, the battery is doing some work in charging these capacitors. Only half of the work, 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 only half of the work is stored as energy. The rest half is lost in the form of heat. Do we understand this?
Yes, sir.
You have 2 minutes. And if I have one more thing, you can write, if I have only two capacitors in series, for two capacitors in series, you can remember this formula: C equivalent will be equal to C1 C2 upon C1 plus C2. This formula would be very handy when you are finding the equivalent capacitance of two capacitors. Do we understand this?
Yes, sir.
Equivalent capacitance of two capacitors. This formula will come in handy. So I'll give you 2 minutes to note this down. Let me see if I can tell you one more thing. If you have three capacitors in series, if you have three capacitors in series, then if you want, you can use this formula: C1 C2 C3 divided by C1 C2 plus C2 C3 plus C1 C3. Remember, the number of things that you can recollect and you can use and you can calculate faster, that is what is required in your JEE. I'll give you a minute to note this down. Okay, then we can move ahead and solve this question. In this question, there are 3 or 4 questions asked here, but we will try to find out everything, so that in one question we can do all the things that can be asked. The first question is, you have to find out the charge on each of the capacitors, the charge flowing through each of the capacitors, or charge deposited on each of the capacitors would be same, yes or no?
Yes, sir.
And that will be the charge that flows through the battery, yes or no? So you have to find the charge that flows through the battery, or charge which is deposited on each of the capacitors. You have to find out the potential difference across each capacitor. If I call this as V1, if I call this as V2, and if I call this potential difference as V3, you have to find out the value of V1, V2, and V3. You also have to find out the energy stored in each capacitor. Here they have only asked the energy on the 3 microfarad capacitor, but you can find out the energy on all the three capacitors, the total energy, and the heat produced in this circuit. Before finding out the heat produced, you can also find out the work done by the battery. So in one question, we are done with all the questions that can come in this particular type. Do we understand this?
Yes, sir.
I'll give you 2 minutes to give me the answer. Okay, so let me solve this question. We can replace this circuit by a single circuit with a single capacitor, yes or no?
Yes, sir.
What will be the equivalent capacitance of this? It will be 1 by 2 plus 1 by 3 plus 1 by 6, and we inverse that 1 by 2 plus 1 by 3 plus 1 by 6. What will happen? What will be the equivalent capacitance of this?
1, sir.
1 microfarad will be the equivalent capacitance. Now you can find out what is the charge that is flowing through the battery or charge flowing through all this combination. It will be 30 microfarad. Q is equal to CV. Yes or no?
Yes, sir.
Sorry, 30 microcoulomb. What is the potential drop across each capacitors? The total potential drop is 30 volt, and the total charge that is flowing is 30 volt, 30 microcoulomb. So from there you can find out the value of V1. The value of V1 will be 15 volt. The value of V2 will be 10 volt, and this will be 5 volt. As you can see, it is in the inverse ratio of capacitance. Yes or no?
Yes, sir.
What is the potential energy in the 3 microfarad capacitor? You can find it out from Q square by 2C. Yes or no?
Yes, sir.
Q square by 2C. If you find out that value, I think you will get it as 150 microjoule. Yes or no?
Yes, sir.
To find out the total energy of the capacitors in all the capacitors, you can find it out by U square by 2 times C equivalent. Yes or no?
Yes, sir.
And I think that answer is going to come as 450 microjoules. Yes or no?
Yes, sir.
What is the heat produced in the circuit? For before doing that, you can find out what is the work done by the battery. Work done by the battery will be 30 microcoulomb multiplied by 30 volt. It will be coming as 900. Yes or no?
Yes, sir.
And half of this is stored as energy and half of this is going in the form of heat. Everyone got this answer? Yes or no?
Yes, sir.
Everyone got this? Yes or no? Can I move ahead? Yes or no?
Yes, sir.
Pakka?
Yes, sir.
Okay, now having done this, we can do the brother of this. The brother of this is the combination of registers, 3 registers. So we can, as I was saying, we can do the same thing with registers. 3 registers are put like this. What is going to happen here? The same current is going to flow, yes or no?
Yes, sir.
To the 3 registers. Potential difference across them would be different. So V1, V2 and V3. V1 will be equal to I1 into R1, V2 will be equal to I into R2, and so on. Yes or no?
Yes, sir.
Then you can replace these 3 by one register. That register will be known as the equivalent register. Yes or no?
Yes, sir.
R equivalent. The same current will flow V. We can write V is equal to I into R equivalent, and the value of this R equivalent will be equal to summation of Ri. Do we understand this?
Yes, sir.
Here what will happen is this register resistance will be more than the resistance of the biggest resistor. Yes or no?
Yes, sir.
Now we talk about energy in a capacitor. When we talk about a resistor, we talk about heat energy lost in the resistor. So power lost in the resistor in the form of heat is always given by this formula: I square into R, or V square by R, or V into I. Do we understand it?
Yes,
This
sir.
is the energy or power, not energy, power. Power lost in the resistor in the form of heat. Energy lost in the resistor in the form of heat will be I square R multiplied by T, V square by R multiplied by T, or VI multiplied by T. So when you multiply this by T, you will get the energy lost in the resistor in the form of heat energy. Do we understand this?
Yes, sir.
So the same thing comes here. The only thing is Instead of inversing them and adding them, we add them directly over here. Here, we understand this, everyone?
Yes,
I'll
sir.
give you 2 minutes to note this down. Well, let's move ahead. And solve this question. In this question, they have only asked find out the current in the circuit, but apart from finding out the current, you also tell me the potential drop across each resistor, and you also tell me the power dissipated in each resistor. So apart from current, you have to tell me what is the voltage and what is the power in each resistor. Do we understand?
Yes, sir.
In each resistor, what is the power dissipated and what is the voltage? I will give you a minute to note this down to solve this problem. So how are we supposed to do this? First of all, we can find out the equivalent resistance. What is the equivalent resistance of this?
6, sir.
This is 30-volt battery, so this will be 6 ohms. So you can now find out the current which is flowing in the circuit. V is equal to IR. The current will be 5 amperes. Yes or no?
Yes, sir.
Once you have find the value of the current, you can find out the resistance, the potential drop across this resistance. This will be 5 volt, this will be 10 volt, and this will be 15 volt. Yes or no?
Yes, sir.
So as you can see, the potential drop is in the same ratio as the resistance. Do we understand this?
Yes, sir.
To find out the power in the 1 ohm resistors, what you can do is you can find out I square into R. I square is 25, resistance is 1, so this will be 25 watt. Yes or no?
Yes, sir.
One will be 25 watt, the power to the second one will be 50 watt, and the power to the third one would be 150 watt. Yes or no? Everyone understands this? Yes or no?
Yes, sir.
Okay, that takes us to the next type of combination, and the next type of combination is known as the parallel combination.
Power in the third resistor is 75 watts.
Yes, 75 watt. I probably wrote it multiplying by 50. It should be multiplied by 25. Do we understand this?
Yes, sir.
Okay. The next one is the parallel combination. In this parallel combination, what is happening is, as you can see, one plate of all the capacitors are connected to one point here, and the other plate is connected to the other point here. In such a case, the capacitor will come in parallel. Do we understand this?
Yes, sir.
Here, all the capacitor will have the same potential difference, but the charges on them would come different. Do we understand this? Yes or no?
Yes, sir.
Q1, the charge on the capacitor first will be C1, V1, and so on. Do we understand this? Yes or no?
Yes, sir.
The charge on each of the capacitors will be in the direct ratio. Do we understand this?
Yes, sir.
The capacitor which has more charge, more capacitance will have more charge, and so on. Do we understand this?
Yes, sir.
You can find out Q1 in terms of Q, Q2 in terms of Q, and Q3 in terms of Q. Yes or no?
Yes, sir.
We can replace these three capacitors by a single capacitor. The equivalent capacitance of this capacitor will be C equivalent, and the total charge will be Q. This Q will be equal to Q1 plus Q2 plus Q3. Yes or no? Do we understand this? And
Yes.
that will be equal to C equivalent multiplied by V. From there you can find out C equivalent will be summation of Ci. Do we get this? Yes or no?
Yes, sir.
Everyone is able to understand what we have written here?
Yes, sir.
I'll give you 2 minutes to note this down. Okay, then we can write this. The energy of the combination can be written as half C1 plus C2 plus C3 and so on V square. Here V is common. Here V is common, so we can see that the energy stored in each capacitor U1 is to U2 is to U3 will be in the direct ratio of capacitance. Do we understand this?
Yes, sir.
And the total energy stored divided by work done by the battery will be half of the energy is stored and the other half is lost in the form of heat energy. Do we understand this?
Yes, sir.
I'll give you 2 minutes to give me the to note this down. Then comes this question. Here we have three capacitors in parallel. We have to find out everything in this question apart from the question that is asked. We have to find out the equivalent capacitance. We have to find out the charge coming on each capacitor. You have to come out the total energy, total heat, potential energy, and whatever. I'll give you 2 minutes to give me the answer fast. So how are we supposed to do this? We can find out the equivalent capacitance of this combination. What will be the equivalent capacitance?
6.
It will be 6 microfarad. Do we understand this?
Yes, sir.
Then from there you can find out the total charge which has flown through the battery. The total charge which has flown through the battery will be 6 multiplied by 10. That will be equal to how much?
60, sir.
60 microcoulomb. Now once you know the value of the charge that has flown through, you can find out the charge that has flown through each of the individual, or the easier way is, you know, the potential difference across each capacitor is 10 volt. Yes or no?
Yes, sir.
So from that we can find out the charge coming on each capacitor. The charge coming on this capacitor will be 10 multiplied by 1. It will be 10 microcoulomb. Yes or no?
Yes, sir.
On this one it will be 20, and on this one
But
it will be 30 microcoulomb. Do we understand this?
yes, sir.
To find out the energy stored in the total energy stored in the capacitors, you know the total capacitance or equivalent capacitance is 6. You know the battery is 10 volts, so you can do it in any ways. The total energy stored, you can find it in any ways. You can do it with this half
Half C equivalent.
equivalent into V square. Yes or no?
Yes.
Heat produced in the circuit. To find out the heat produced in the circuit, you can find out the work done by the battery. Work done by the battery will be charge flown to the battery into V. Charge flown through the battery is 60 microcoulomb, and the battery voltage is 10, so this will be 600 microjoule. Yes or no?
Yes, sir.
And you will find out that the total energy will be half of this. Yes or no?
Yes, sir.
And the energy lost in the form of heat will be the other half, 300 microjoules. Everyone got this answer? Yes or no?
Yes, sir.
Anyone has any doubts on this?
No, sir.
Then we can quickly go through the cousin brother of this, and the cousin brother of this looks like this. It would be series combination of resistors. Yes or no? No, yes.
Parallel combination.
Sorry, parallel combination of resistors. Again, the potential would be same, but current would be different, and current would be inversely proportional to the resistance. That is a very important fact. Current is inversely proportional to the resistance. More resistance, less current, less resistance, more current. Do we understand this?
Yes, sir.
So current flowing will be inversely proportional. We understand this, yes or no? We can
Yes.
replace this circuit by a single resistor, and the circuit will look like this. Oops, so I am drawing capacitor. I must have drawn resistor. This resistor will be connected across the same battery R equivalent. The current I will be equal to I1 plus I2 plus I3, and this V will be equal to I into R equivalent, and the value of this R equivalent will be given by this formula. Yes or no? No, yes.
Yes, sir.
I'll give you 2 minutes to note this down. Then you can solve this question. In this question, again, you have to do all the parts. The first part is find out the equivalent resistance. The second part is find out the current in each branch. The third part is what is the current flowing to the battery. The fourth part is what is the power dissipated in each resistor. The fifth part is what is the total power developed. I'll give you 2 minutes to give me the answer. So I think you would have done this. What will be the equivalent resistance?
1.
Equivalent resistance will be 1 volt. What will be the current that is flowing through the battery?
30. 30 ampere.
30 amps. What is the current through this branch? You don't have to do anything. You know the voltage is 30 and you know the resistance is 2. So V is equal to IR. So current through this branch will be 15 amperes. Yes or no?
Yes, sir.
This will be 10 amperes and this will be 5 amperes. Everyone got this answer? Yes or no?
Yes, sir.
To find out the power, you can use the formula V square by R because V is same. V square is 900 divided by 2. This is the power to the first resistor. 900 divided by 3 will be the power to the second resistor, and 900 divided by 6 will be the power dissipated in the form of heat through the third resistor. You add all this, or you can simply do the power. Total power will be I square 30 square into R. No matter how you do it, you will always end up with the same result. Do we understand this?
Yes, sir.
You'll have to do the problem in the shortest possible way because you have to save time. Do we understand this, everyone?
Yes, sir.
Everyone got this? Can I have some raise hand with everyone that we have understood this? What we are doing here? Yes or no?
Yes, sir.
Then the same thing that we have done, this is now put in the form of a tablet or of a table. On the left hand side, we have series grouping. On the right hand side, we have parallel grouping. In the series grouping, total voltage is V1 plus V2 and so on. In the right hand side, total charge is Q1 plus Q2 and so on. C equivalent is given in both sides. Voltage in series combination is in the inverse ratio of capacitance. Charge in the parallel combination is in the direct ratio of capacitance. Do we understand this?
Yes, sir.
I'll give you a minute to note this down. Then you can move on to the next 4 and 5 points. If two capacitors C1 and C2 are connected in series and the total potential drop is V, V1 will be equal to C1 upon C1 plus C2 and V2 will be equal to C1 plus C2, C2 upon C1 plus C2. Do we understand this? This is how voltage divides in series combination. We understand this, everyone?
Yes, sir.
Similarly, if you have a charge Q and this is dividing in C1 and C2, the charge will divide in the direct ratio. Here this formula is given wrongly. Potential will divide in inverse ratio. So just correct the formula. Potential V2, V1 will be C2 upon C1 plus C2 into V, and V2 will be equal to C1 upon C1. Here it is in inverse ratio. You can see this is inverse ratio. Do we understand this?
Yes, sir.
And charge will divide in the direct ratio. Do we understand this?
Yes, sir.
If you have n equal capacitors connected in series, equivalent capacitance will be C by n, and equivalent, and the voltage through each capacitor, voltage drop across each capacitor will be V by n. Similarly, if you have n capacitors connected in parallel, equivalent capacitance will be n times C, and the charge on each capacitor will be Q by n. Do we understand this, everyone?
Yes, sir.
I'll give you a minute to note this down. Okay, again, then these are some important points. We have already discussed most of them. Just note them down. For a given voltage, to store maximum energy, capacitors should be connected in parallel. In parallel, the capacitance becomes C1 plus C2, the energy becomes half C1 plus C2 and so on V square. So in that case, you will have maximum energy. Do we understand this?
Yes, sir.
I've seen a question of this breakdown voltage. What do you mean by this breakdown voltage? This is the maximum voltage a capacitor can sustain. Now, if you have capacitors connected in series, each capacitor will have a breakdown voltage of V volt. Therefore, the breakdown voltage of the combination will become N times V. So, if you want to make the breakdown voltage of the combination more, you will connect them in series. If you want to make it same, you will connect the capacitors in parallel. Do we understand this?
Yes, sir.
Two capacitors when connected in series with a battery, if the battery is removed and the capacitors are connected to each other without the battery, the final charge on each capacitor would be zero. We understand this. This line in DC, the capacitor offers infinite resistance current through any capacitor. DC current through any capacitor in any branch where capacitor is connected in a DC circuit, there will not be any current flow. We will see this in brief as well. We will see this in a lot of detail in the next class that is coming up. Right now, you just write it. If n identical capacitors are connected in series, it becomes C by n. In parallel, the equivalent capacitance becomes n times C. We understand this?
Yes, sir.
2 minutes, you have to note this down. Then we move to this part. In this part, what you can see is we have the same thing, but in terms of series combination of resistors. Three resistors are in series, three resistors are in parallel. The equivalent resistance becomes R1 plus R2 plus R3. In that case, it becomes the inverse of 1 by R1 plus 1 by R2, 1 by R3, that is 1 by R. The power in the first case is in the direct ratio of resistance. The power in the second case is in the inverse ratio of the resistance. I'll give you 2 minutes to note this down. Three or more points are there, so make a bigger table. So we can now move on to the next point. And the next 2 points are like this: equivalent resistance for two resistors. The equivalent resistance is given by R1 R2 upon R1 plus R2. For three resistors, it is given in this form. Do we understand this? I'll give you 2 minutes to note this down. We have already discussed all of these. Okay, then we can move on to the next 2 points. And these are the next 2 points. We have already discussed them. I'll give you 2 minutes to note them down. Then we will move on to the next thing, and this is the series parallel combination. We will be solving question on equivalent resistance and series parallel combination. So questions on series parallel combination of resistors and capacitors. How are we going to solve them? We have to change them into simple forms. For example, we have to find the equivalent resistance between points A and B of this. How will you do it? I'll give you 2 minutes to think about it. So how are you going to do this? This 3 and this 6 are in series combination. Yes or no?
Yes, sir.
That will give us 2 microfarad. This 2 microfarad and this 3 microfarad will be in parallel. So the answer would be 6 microfarad. Do we understand this? Yes or no?
Yes, sir.
Okay. Then comes this one. What will be the equivalent resistance between the points A and B here? I'll give you 2 minutes to do this. Between A and B, we have to find out, and you can see this 6 and this 6 are in series, so it becomes 3. 3 and 3 are in parallel, it becomes 6. 6 and 6 are in series, it becomes 3. 3 and 2 are in parallel, the answer becomes 5 microfarad. Do we understand this? Yes or no?
Yes, sir.
What is the equivalent resistance in this case? I'll give you 2 minutes to think about it. 3 microfarad, it is correct. This 9, and this 9 are in series, so it becomes 3. Yes or no?
Yes, sir.
3 and 6 would be in parallel, it becomes 9 again. 9 are in series, it becomes 3 again. 3 and 6 are in parallel, it becomes 9 again. 9 in series, it becomes 3 again. I call such combination as series parallel, series parallel. Once they are in series, then are in parallel, then in series, then in parallel. Do we understand this, or this has gone above our head saying bye bye?
We understood, sir.
Pakka?
Yes, sir.
Then this one. You have to find the equivalent resistance between A and B, points A and B. I'll give you 2 minutes. So how are we supposed to do this? Again, this is in the same type that I call series parallel combination. 2 and 2 are in R and R are in series, it becomes 2R. 2R and 2R are in parallel, it becomes R. R and R in series, it becomes 2R. 2R and 2R in parallel becomes R. R and R in series becomes 2R. 2R and 2R in parallel becomes R. R and R in series becomes 2R. 2R and R are in parallel, it becomes 2R by 3. Do we understand this? Yes or no? No, yes.
Yes, sir.
Oh, this has gone above our head saying bye bye. Bye bye, bye bye. I'm going bye bye.
We understood, sir.
Pakka, you have understood?
Yes, sir.
You have to find the effective resistance between points A and B. What is the answer for this one?
Six microfarad, sir.
6 microfarad. How did you get 6 microfarad? This 12 and this 6 are in series. Yes or no?
Yes, sir.
12 and 6 in series. Remember, they are capacitance. 12 and 6 in series becomes 12 into 6 divided by 12 plus 6. That is coming as 4. Yes or no?
Yes, sir.
This 4 and this 2 are in parallel, so the answer would be 6. Do we understand this?
Yes, sir.
What about the next one? What is the equivalent capacitance of this diagram?
9 mu F, sir.
It is
8.
very simple because these three are in a series. So 6 in series becomes 3. 6 in series becomes 2. And 2 and 6 are in parallel. Yes or no?
Yes, sir.
2 and 6 are in parallel. 2 and 6 in parallel will give you 12 divided by 8, 4 by 3, I think. 4 by 3 would be the answer. Do we understand this?
Correct, 4 by 3? No.
You got the answer, yes or no?
So the answer is 8, right?
Oh, sorry. 2 and 6 are in parallel, it will become 8. Sorry, I got confused. The answer is 8. Do we understand this?
Yes, sir.
Everyone got this?
Yes, sir.
Then comes this one. What is the equivalent capacitance between A and B? In this case, I'll give you 2 minutes to think about it. The answer is definitely 3 C's because there is no, if this point is A, this point also becomes A because it's connected by a wire, there is nothing here. This point is A, this point also becomes A because if you can see here, there is no wire, there is no resistor, no capacitor, so all the points are A. If I go on the other side, if this point is B, this point is also B, and this point also becomes B. I hope you understand what I'm saying here. Yes or no?
Yes, sir.
Now, if you draw what I call it's the equivalent diagram, if you draw what I call the equivalent diagram between A and B, you will see that there are 3 capacitors connected. Yes or no? Just like this. This capacitor, the pink capacitor is connected here, the green capacitor is connected like this, and the blue capacitor is connected like this. So basically these 3 capacitors, as you can see very clearly, they are connected in series, they are connected in parallel, and therefore the equivalent resistance or equivalent capacitance will become 3C. Do we understand this?
Yes, sir.
What will be the answer in this case? Question has been changed from capacitor to resistor. What would be the answer in this particular case? What would be the answer in this particular case?
R by 3?
And in that
R
particular
by
case, the
3.
answer would be R by 3. This is the same question but put in the form of register. No matter how you put it, the answer remains same. All these three are in parallel, so the effective combination becomes R by 3. Do we understand this?
Yes, sir.
So whatever questions we are doing in capacitors, same question can be made in resistors. If capacitors are in series, resistors would be in series. If capacitors are in parallel, resistors would be in parallel. The only difference is they will get added up in different ways. Do we understand this?
Yes, sir.
Next question is this question. Between A and B, you have to tell me the equivalent capacitance.
2C, sir.
2C, why it is 2C? Now remember this point is A, so this point is A, this point is A, and this point is A. Now this capacitor, both the points are connected to the same point, so this capacitor does not come into the picture. So the equivalent diagram, if you see, there are only 2 capacitors connected between A and B, so the equivalent capacitor will become 2C. Do we understand this? Yes or no?
Yes, sir.
Everyone understands this?
Yes, sir.
Are we able to follow me, or am I going too fast? The next one is this one. 3 capacitors connected like this. What is the equivalent capacitance? In this case,
So 3C.
3C, all these capacitors are connected. All these capacitors are connected in parallel. Do we understand this? Yes or no?
Yes, sir.
Everyone is able to understand this? Yes or no?
Yes, sir.
This is the next one. What is the equivalent capacitance between points A and B? I hope you are following it. You have 2 minutes to give me the answer. 5C by 3 is the correct answer. You can see this point is A, this point is A, this point is also A. But then this point is becoming different because it is connected differently. So this point is C. Between A and C, if you can see, these two are connected in parallel. Yes or no?
Yes, sir.
So it becomes 2C. Between A and C, it becomes 2C. Do we understand this?
Yes, sir.
Then after that, between A and C, we have found it out. Now, how do I go about from there? How did I get 5C by 3? So then this 2C that we have got, this 2C and this C will be in series. Yes or no?
Yes, sir.
C and 2C in series, we will get 2C by 3. Yes or no?
Yes, sir.
That 2C by 3 and this C will be in parallel. So the answer would be 5C by 3. Everyone understands this?
Yes, sir.
Pakka?
Yes, sir.
Then we have this one, the last one in this type. It looks like the same question. The only thing that I have done is this C has been removed from here. Now what is the equivalent capacitance between A and B?
Zero, sir.
It is 0, sir, because all these points, whether you start from this point, this is A, everything is A. So the equivalent resistance in this case becomes 0. Do we understand this? There is no resistor coming. There is no capacitor coming between points A and point B. We understand this? Yes or no?
Yes, sir.
Everyone understands this? The next thing that you have to understand in solving the equivalent circuits is balance Wheatstone bridge. Have you heard about this balance Wheatstone bridge?
Yes, sir.
What is this balance Wheatstone bridge? If you have any circuit like this,
C1 by C3 is equals to C2 by C4, then C5 is short circuited, sir.
right? If we have this scenario where C1 by C2 is equal to C3 by C4, no matter how you write it, nothing comes here. The voltage of point B, here it is written as E. The voltage of point E and the voltage of point D becomes same. Do we understand this?
Yes, sir. Sir, can we take like C1 by
So
C?
then you can solve this question in different ways. C1 and C2 are in series, C3 and C4 are in series, and then they are in parallel. Do we understand this?
Yes, sir.
That is one way of solving it. The other way of solving it is you can take C1 and C3 in parallel. You can take C2 and C4 in parallel, and then you can take the combination in series. So no matter how you do it, you will always end up with the same result. Do we understand this?
Yes, sir.
So C1, C2 can be taken in series, C3, C4 can be taken in series, then they can be taken in parallel, or C1, C3 can be taken in parallel, C2, C4 can be taken in parallel, and then they can be taken in series. Do we understand this?
Yes, sir.
Everyone understands this?
Yes, sir.
The same thing can be said for equivalent resistance. If you have resistance connected in that fashion, if R1 by R2 becomes equal to R3 by R4, it becomes a balanced Wheatstone bridge, and you can solve the question in that way. Do we understand this?
Yes, sir.
Everyone understands this? Everyone understands this?
Yes, sir.
Then this is the first question that we are going to solve. What is the equivalent equivalent capacitance between points A and B? So how are you going to solve this? What you have to notice is this is 1 and this is 2. This is 3 and this is 6. So 1 by 2 is equal to 3 by 6. This forms what?
Balanced Wheatstone bridge.
This forms balanced Wheatstone bridge. So this goes away. Now you can solve it in various ways. I am going to do it by the second way. I can take these two in parallel. 1 and 2 are in parallel. How much it becomes?
3, sir.
3 and 6 are in parallel. How much it becomes?
9.
Then the 3 and 9 are in series. 3 and 9 in series, it will be 27 divided by 12. Yes or no?
Yes, sir.
That is the answer. Whether you do it in this way or you do it in the other way, the answer remains same. Do we understand this, or this has gone above our head saying bye bye?
Understood, sir.
Pakka, sir? Everyone?
Yes, sir.
Girls, are we there in the class? This is the next question in the same series. What is the equivalent capacitance between A and B? This is the same question. You put it like this or you put it another way, the concept remains the same. This question is the same. Do we understand this? Yes or no?
Yes, sir.
Girls, do we understand this? Or this is going above our heads? Saying bye bye. Bye bye, I'm going bye bye.
Understood, sir.
Then this one. I'll give you 2 minutes to solve it.
Sir, 45 by 29.
So how are we supposed to do this? Let me call this point is A. This point will also be A. This point is B. This point will also be B. But now this point, because there is a capacitor coming here, this point cannot be A. So let me call this point as C. This point here, since there is a capacitor over here, I cannot call it as B. Let me call it as D. I have to find the equivalent capacitance between points A and B. What I'm going to do is redraw the circuit. This is point A, and let us say this is point B, and let me draw the circuit. Somewhere lies point C. Between A and C, let me just put C here. Between A and C, we have a capacitor of 1 microfarad. So let me draw the capacitor of 1 microfarad over here. Then between C and B, there is a 3 microfarad capacitor. So I can put this 3 microfarad capacitor here. This is your blue capacitor. So basically what I am doing here is just redrawing the circuit. Somewhere in between there is point D. Between A and D, you see this 2 microfarad capacitor. So between A and D, this 2 microfarad capacitor comes into the picture. Between D and B, you can see this 6 microfarad capacitor between D and B. I connect this 6 microfarad capacitors between point D and point B. One more capacitor is left, this green one. It is connected between C and D. So I connect this green one between C and D. And now you can see, how does it look like? It looks like
Balanced Wheatstone bridge.
a balanced Wheatstone bridge. So the answer is same. So even if they are connected in this fashion, they are connected in the same way. It's just the diagram is drawn in a different way. Do we understand this? How this is done?
Yes, sir.
Everyone understands this? Everyone understands this?
Yes, sir.
This is the next question. You have to find the equivalent capacitance between points A and B. I'll give you 2 minutes to do this. So how are we supposed to do this? You look at this 2, you look at this 4, you look at this 4 and you look at this 8. What do you understand from there?
That is balanced Wheatstone bridge, and 5 is.
So this 5 gets cut. Now it's a very simple question. You can do it in any ways. 2 and 6 are in 2 and 4 are in series. 4 and 8 are in series. And then these all three are in parallel. Do we understand this?
Yes, sir.
Anyone understands this? Yes or no? No or yes?
Yes, sir.
Next one is this one. I'll give you a minute to solve this. So, looking at this, 2 and 4, 4 and 8, you can understand that this will go away. Yes or no?
Yes, sir.
This value is not given, but okay. Then looking at this one, 4 and this 2, and this 8 and this 4, you can understand that this one will go away. Yes or no?
Yes, sir.
And similarly, this one will go away. All of them are going away. Yes or no?
Yes, sir.
These are in series, these are in series, these are in series, these are in series, and then they are in parallel. You can solve it that way also. Do we understand this, or this has gone above our head saying bye bye?
Understood, sir.
Everyone understands this? Yes or no? No or yes?
Understood, sir.
This one, the more the number of questions you solve, the better you are going to be. You have to get me the value of capacitance between A and B. The answer is 2c/3. Nothing will come in this. Yes or no?
Yes, sir.
Everyone understands this? Boys and girls, everyone understands this? Next one. This one. What is the answer for this one? Yes?
2, sir.
This is again of that same type. These two are in series. So it becomes 1. Then it becomes 2. Because they are in parallel. Yes or no?
Yes, sir.
Then 2 and 2 are in series, it again becomes 1. 1 and 1 are in parallel, it becomes 2. Do we understand this, everyone?
Yes, sir.
Series parallel, my favorite. Comes this one. All the capacitors are 3 microfarad, or all the capacitors are 3 microfarad. Everyone is 3 microfarad. Equivalent capacitance of this. This is point A, this is point A. This is B, this is also B. Do we understand this?
Yes, sir.
And this is C. Now you can redraw the circuit and see how the circuit is coming. Between A and C, how many capacitors are connected? 1, yes or no?
Yes, sir.
So you can connect one over here. You can connect one over here. This one is gone. Between C and B, how many are connected? This green one and this blue one. Yes or no? 2 are connected.
Yes, sir.
C and C, I mean 3 and 3 are in parallel. So we can put 3 by 2 in series. Yes or no?
Yes, sir.
Are we able to understand what I'm saying?
Yes, sir.
Then this one is connected between A and B. So you can connect it like this. And this would be your equivalent circuit. Yes or no? 3
Yes.
and 3 by 2 are in parallel, are in series, and then it is in parallel with 3. What is the answer that you are getting? Have I done it correctly or wrongly?
Yes, sir. It is correct, sir. 11 by 2.
I've done it wrongly. This green one and this blue one are in
Parallel, sir.
parallel. I've added it wrongly. I've added it 3 by 2. So 3 and 3 in parallel becomes 6, not 3 by 2. That is the mistake I have done. Do we understand this?
Yes, sir.
Sometimes I get, between resistance and capacitance, I add them wrongly. So 6 and 3 are in series, so it becomes 9. 9 and 3 are in parallel. The answer becomes
Sir, 6, 3, and it will become 6 by
6 and 3 are in series, it becomes 2. 2 and 3 are in parallel, it will become 5. Do we understand this?
Yes, sir.
Everyone understands this?
Yes, sir.
Give the answer to of this one fast. So the answer is just about calculating. You just have to calculate this 6 and 12 are in series, yes or no?
Yes, sir.
Then they are in parallel, yes or no?
Yes, sir.
2 and 2 are in parallel, yes or no?
Yes, sir.
Then they are in series, yes or no?
Yes, sir.
This entire thing is in series and this entire thing is in series, yes or no?
Yes, sir.
Then they are in parallel,
Yes, sir.
then this entire thing is in series and the
Yes.
answer is given as 1, yes or no?
Yes, sir.
From there, you should be able to calculate the value of this C, and the answer given is 32 by 23. The rest of them is calculation. I hope you can do the calculation on your own.
Yes, sir. Got 32 by 23, sir.
32 by 23. Congratulations. Let us move ahead. Everyone got this? No?
Yes, sir.
This is the next question. What is the equivalent resistance between points X and Y?
Sir.
The answer for this one would be 10. As you can see, this is a balanced Wheatstone bridge. Yes or no?
Yes, sir.
This 20 will not come in the line at all. Yes or no?
Yes, sir.
This 10 and this 10 can be taken in series 20. This 10 and this 10 can be taken in series 20. 20 and 20 are in parallel. The answer would be 10. Do we understand this?
Yes, sir.
Everyone understands this? Everyone understands this?
Yes, sir.
This is the next one. Find the effective capacitance between A and D.
Sir, A and
D. So what is the answer for this one? This one and this one will not come into the picture. Yes or no?
yes, sir.
These two are in series, 10 and 10 in series, 10 and 10 in series, 20 and 20. 20 and 20 are in parallel, so it will become 10. 10, 10 and 10 are in series. The answer would be 30 ohms. Do we understand this?
Yes, sir.
Everyone understands this?
Yes, sir.
The more the number of questions you do, the better you are going to be. This is the next one. What is the answer for this one? So as you can see, this will behave like a balanced Wheatstone bridge. Yes or no?
Yes, sir.
It behaves like a balanced Wheatstone bridge. Then the answer will be same as any one of the resistors, and the answer will be equal to 2 ohms. Do we understand this?
Yes, sir.
One more. This one. What is the answer for this one? I'll give you 2 minutes to solve this. So how are we supposed to solve this? This is the answer is 4 ohms. These two are in parallel, then it is in series. Yes or no?
Yes, sir.
These two are in parallel. These two will be in series, these will be in parallel, and then they will be in parallel. Do we get
Sir,
this? How are we going to do this?
sir, if
Sorry,
it
sorry, sorry,
is
sorry. Yes, I couldn't.
transformed to Wheatstone bridge, sir, 8 ohms is neglected.
Yes, yes, yes. So this becomes 5. This becomes 3. So 5 and 5, 3 and 3, 8 comes out and it becomes a valent Wheatstone bridge. That is correct. That is the way it has to be solved. Do we get this? Yes or no?
Yes, sir.
Now let us move on to this type of question where we have an infinite series, and how are we going to solve that question? So try this one. I'll give you 2 minutes to solve this. What is the equivalent capacitance? No, equivalent resistance between A and B of an infinite network. I'll give you 2 minutes. So how are we supposed to do this? This is point A and B. It's an infinite series. If I look from here, from this point C and D, the series looks same. If I just cut one branch, the series does not become different. That means if I call the resistance between point A and B as X, the resistance between point C and D, which is also point A and B, will also be equal to X. Do we understand this?
Yes, sir.
So now the question looks like this. This is X. This is not there, sorry. This is X. This is 1 ohm. This is 1 ohm. So this X and this 1 ohm are in parallel, yes or no?
Yes, sir.
So this equivalent resistance becomes x upon x plus 1, yes or no?
Yes, sir.
Now this x upon x plus 1 comes in series with this 1, yes or no?
Yes, sir.
So the equivalent resistance becomes x upon x plus 1, yes or no?
Yes, sir.
And that again must be equal to the resistance between point A and B, and the resistance between point A and B is again equal to x, yes or no?
Yes, sir.
This is a quadratic equation that you have to solve and get the value of x. And now give me the answer. What is the value of x? Do we understand how I have done this? Again, I will repeat it. What I have done is I have assumed that the resistance between the points A and B is x. Then I move one link ahead and go to point C and D. If I look from the point C and D, the resistance is still same. Do we understand this?
Yes, sir.
Now I'll give you 2 minutes to note it down and give me the answer.
Yes, sir.
So any question that comes in this category, it has to be done in this way. So do not forget this. This is a very important concept, and you might get a question on this. You never know. Now this is a question taken from S.C. Verma. We are only going to do the first part of it, where they are asking you to find out the equivalent resistance. This is the question, and I'll give you 2 minutes to give me the answer for this one. You just have to find out the equivalent resistance. You are just solving the first part. Find the effective resistance. Once you get the effective resistance, current passing will be very simple.
Equivalent resistance is 2 ohms, sir.
2 ohms, I think, is the correct answer. If I call the resistance between A and B as X, the resistance between this point C and D, which is also A and B, will also be equal to X. Yes or no? Then the circuit will look like this, and I'm drawing the circuit in very short. This would be X, this would be 2, this would be 1, and this would be A and B. This X and 2, as you can see, are in parallel. The effective resistance becomes 2x upon x plus 2. Do we understand this?
Yes, sir.
Then this is in series with this 1 ohm. So the effective resistance of this combination becomes this plus 1. Do we understand this?
Yes, sir.
And this must again be equal to x, because the equivalent resistance is equal to x. So this is equal to x. This is a simple quadratic equation, and I think that will give you two values. One value will become negative, that is not possible. The other value will be coming as 2 ohms. Do we understand this? Yes or no? No, yes.
Yes, sir.
Everyone understands this.
Yes,
How
sir.
this is done?
Yes, sir.
Okay, I'll give you one last on this. That will come from this one. And I hope that you have understood this. In the next class, we will go ahead and solve more problems. Have you understood this concept
Yes, sir.
of finding out the series parallel combination of resistors? This is the last one in this. We have done it for resistors, so it is also useful to do it for capacitor. This is an infinite combination of capacitors. Give you 1 minute to give me the answer for this one. Equivalent capacitance between A and B. So I think you got the answer for this one as well. On similar lines, if I call the effective capacitance here as X, then from here also it becomes X. Yes or no?
Yes,
So I
sir.
can draw the equivalent diagram. It looks like this. 2x 1, and this is also x. Do we understand this? This
Yes, sir.
x and 2 are in series, So the effective combination becomes 2x upon x plus 2. Then they are in parallel. So it becomes plus 1. That should be equal to x. This is the same equation that we got in the previous case. Therefore, the answer for this one is also going to come as 2 microfarad. Do we understand this, everyone?
Yes, sir.
Okay, then we have finished series parallel combination. I have also sent you a sheet. Did you get that sheet on series parallel combination on electrostatics and electric current? Did you get that sheet? Yes or no?
Yes, sir.
Have you started solving that sheet?
Yes, sir.
Okay, so
Yes,
solve
sir.
that sheet, and even if you are able to solve 10% of the sheet, that is good enough. If you are able to remember the questions that we have done in the class, that is more than enough, because questions are coming from the same thing as well. And I hope you have realized it from the attempt that you have given. Yes or no?
Yes, sir.
So then I'll wind up this class here. In the next class, we will move ahead and we will solve questions on circuits. I will wind up your series parallel combination here, because only questions from this part are going to come. So in the next class, we'll move on and solve circuits and see how we can solve question when you have circuit and you're supposed to find the current or the voltage or the charge on the capacitor in the circuit. So we'll see that in the next class. Take care. Have a good day. Bye bye.
Bye, sir.